Good morning, students. I welcome you all to the class today. Last week we talked about equilibrium. We talked about equilibrium of bodies, and we treated many examples in which many of you were not clear about. So this week I'm repeating the example, and I decided to make audio presentation in order for some of you to understand it better. The first example that was treated last week, we will start from it. A light beam AB sits on two pivots or supports C and D. A load of 10 Newton hangs at 0.2 meters from the support at C. Find the value of the reaction forces P and Q at C and D. Take the distance as shown below. Now, if you look at the diagram, we will see that the force 10 Newton is placed at 2 centimeter distance 2 centimeter from support C, and is actually acting downward. The arrow there indicates direction of the force 10 Newton, and at end A of the light beam, our light beam is AB. So at end A of the light beam, from end A to support C, the distance is 4 meters. Then from support C, or rather from point P, from reaction P to reaction or the weight 10 Newton, the distance is 2 meters. So therefore, the distance of 10 Newton from support C is 2 meters. While the distance of reaction Q from reaction P is 6 meters plus 2 meters. That gives 8 meters. So therefore, the distance of reaction Q from P is 8 meters. I believe that is clear. So let's proceed. Now we will solve the problem from condition of equilibrium of bodies. From the condition of equilibrium, the first condition that was given to you when I was taking the class, the algebraic sum of all the forces about a point must be equal to 0. That is, the sum of upward forces, the sum of the forces acting in the upward direction. I'm talking about the forces P and Q. They are the only one acting in upward direction. Must be equal to sum of the forces acting downward. That is why we call it equilibrium. The object must be at what? A resting position. Must be at a rest position, which means the forces acting upward must be equal to the forces acting downward if the object must be at peace, at rest. So therefore, we'll make use of this condition. The two forces acting upward are what? P and Q, and the only single force acting downward is 10 Newton. So we said from the condition that the sum of the forces up must be equal to the sum of the forces acting downward. So therefore, P plus Q, force P plus force Q, or reaction P plus reaction Q, must be equal to 10 Newton. We'll call this equation 1. We call this equation 1. So let us proceed to the second condition of equilibrium of body. Now, from second condition of equilibrium of body, the total clockwise moment must be equal to total anticlockwise moment. Total clockwise moment must be equal to total anticlockwise moment. What do we mean by clockwise moment? If you go back to the diagram, you realize if you take moment, let us take moment at C, which means we will virtually or imaginely remove, let us remove reaction D. If we remove reaction D, if we remove support D, support C will remain there. And let's assume the object is flexible. It can easily move on the at support C. Then the reaction, the weight of the object, the force 10 Newton, will be dragging the load down if support D is removed. Therefore, the object AB, or the light beam AB, will tend to move downward in clockwise direction with a force 10 Newton. So that means 10 Newton is a force that is in clockwise direction. But if this object is not going to fall down, the only thing that can drag the object back upward from falling is the reaction Q. I mean, when we remove support D, the object will always the object will fall down. The object will fall down. So for this object not to fall down, the only thing that we prevent the light beam AB not to fall down is the reaction Q. Then the reaction Q will drag the light beam AB back upward in anti-clockwise direction. So therefore, the clockwise force we have is 10 Newton, while anti-clockwise force we have is Q. So let's go back and make use of this. So from the second condition of equilibrium, total clockwise moment must be equal to total anti-clockwise moment. So if we take moment at C, we will have 10 Newton, which is the clockwise moment, times 2. Where is 2 coming from? This 2 is the distance from the earlier, what I said earlier on. The 2 now represent the distance of the force 10 Newton from where the force is hanging to support D. The distance between the force 10 Newton and support D is 2 meters. So that is where the 2 meter is coming from. Now if you go to reaction Q, the distance of reaction Q to support D, because support D is still remain there, it's only support C is still remain there, it's only support D that will remove. So the distance of reaction Q from support C is 6 plus 2 meters. So therefore, the total clockwise moment is 20 Newton meters, while total anti-clockwise moment is Q times 8. So therefore, 20 Newton meter is equal to 8Q. So dividing both sides by 8, our reaction Q is equals to 2.5 Newton. 2.5 Newton. So if our reaction Q is equal to 2.5 Newton, let us go back to our equation 1, where we say P plus Q is equals to 10 Newton, which means the upward reactions combined together must be equal to downward reaction. So P plus Q is equal to 10 Newton. Already now we have our Q. Let us put Q back into this equation 1. So we now have P is equal to 10 Newton minus Q. 10 Newton minus Q. So if you put the value of Q there, which is 2.5, then subtract that from 10, the value of P, the reaction P, will be 7.5 Newton. I believe that is clear. Now we are done with that question. We'll go to second question that we treated. A pole AB of length 10 meters, a pole AB of length 10 meters and weight 600 Newton has its center of gravity 4.0 meters. Its center of gravity is 4.0 meters. What does that mean? It means that the center at which the weight of the object is acting downward is 4 from end A, which means the center of gravity of this object from end A is at 4 meters and lies on horizontal ground. So the object, the pole AB, is lying on the horizontal ground. Draw a diagram to show the forces acting on the pole when the end B is lifted by a vertical force. We should draw a diagram to show the forces acting on the pole when the end B is lifted by a vertical force. So what does this mean? After putting, let assume we have a log of wood on the floor lying down horizontally, and the center of this log of wood is, we know that the length of our wood is 10 meters, right? So from point A to center of gravity of the wood is 4 meters. So therefore the only force acting downward on this wood is its own weight. The weight of the pole is the one acting downward, which is 600 newton. So that is the arrow you see pointing downward. Then if you are the one to lift this object up at point B, where will your force go? Your reaction will go upward, because you will place your hand under the wood and try to lift it up. So in the process of lifting it up, your reaction, the applied force you are applying, will be lifting the object upward, which means the direction of your force you apply to lift the object, the pole at point B, is upward. So if your reaction is upward, which means that reaction is moving in anti-clockwise direction, but the weight of the object, which is acting downward, is in clockwise direction. Now let us continue with our question now. We have actually drawn the diagram they say we should draw, so we'll proceed. Calculate the force required to begin to lift this end, end B. Calculate the force required to begin to lift this end, to the to begin to lift this end. Full stop. Prove that this force applied at end A will not be sufficient to lift the end A from the ground. What does that mean? What the question is trying to tell us is that we should calculate the required force that you will use to lift the end B upward. What the amount of force to raise the end B of this wood upward? The wood, don't forget, 600 Newton is a very big wood. So it requires a certain amount of force for it to be lifted upward from point B. So that force is what we want to calculate. Then after that, the question is now asking us to prove that if the amount of force we used at point B to raise the wood is applied at point A of this pole, will it be sufficient enough to raise that end up? So we'll go and find out. So let's proceed. Now the clockwise moment from the diagram I just showed you is 600 Newton times 4 meters. What is 4 meters? 4 meters is the distance of the 600 Newton from support A, from point A. 600 Newton is the weight of the object, and 4 meters there is the distance of that weight from support A. So therefore from end A. So therefore the clockwise moment of this object is 600 times 4 meters. Don't forget, moment is force times perpendicular distance. So we make use of this. 600 Newton times 4 meters gives us clockwise moment. Then while our anti-clockwise moment will be P times 10. What is P? P is the reaction, is the amount of force you apply to lift it up, because that's what they ask us to calculate. Now P is representing the amount of force you apply if you are the one lifting the wood up. Then the distance of point P to support. Where is our support? Don't forget, if you put a log of wood on the floor horizontally and lift it at one end, the other end will be its support, because it's the other end at point A that will be touching the ground. So at point A now, the object is having support, because there is where the object is touching the ground. You can demonstrate that by placing your pen. If you are with your pen, if you place it on a table, let one end of your pen be support A and the other end be support B. Then lift your pen up from one end, support B, and you notice that the other end of your pen, which is support A, will be touching the table or the floor. So at that point A, that is where your pen is being supported. So that point becomes the point where your moment will be taken. So therefore, the distance of the force you apply at B for force P to the support A is 6 meters plus 4 meters. And then clockwise anti-clockwise moment will now give us force times perpendicular distance. So perpendicular distance of reaction P from support A is 6 plus 4. That's where we have 10 there. So therefore, our anti-clockwise moment is P times 10. Now from the principle of moment, clockwise moment must be equal to anti-clockwise moment. So therefore, 6 times 4 must be equal to 10p. Then we'll divide both sides by p. So by 10, sorry, and our p is 240 Newton. So to lift this object up at point B, you need a force of 240 Newton if that end must be lifted up. Now the second question is this. This 240 Newton we just got, if you apply that same amount of force at point B, is it going to be sufficient enough to lift the wood up? Let us go and find out. Now to prove that if this force of 240 Newton is applied at A, we have the situation as shown below. Then the force you apply at A is now 240 and it will be lifting the object upward. So in that situation, if you look at it very well, you see that force 240 now, that force 240 acting at A will be going in the direction of the hand of clock. if you are to lift the object up at point A, the force 240 Newton now apply at point A will be going in the direction of the clock. That's why the arrow there is indicating the direction of the force. And the weight of the object is acting downward, and it will go in the direction of anti-clockwise direction. So this is going to clockwise. The other one will be going in anti-clockwise direction. Sorry, the arrow there is wrong. The arrow there is wrong. When you are drawing it, return the direction of the arrow to your right. I'm talking about the force 600 Newton. I'm talking about the force 600 Newton. Where I put the arrow there is not supposed to be there. Please, when you are copying your note, let the arrow be pointing towards your right. Let the arrow be pointing towards the right. So remove the arrow from where I put it and put it on the other side of that anti-clockwise line I draw. So let us continue. Now if you take moment now at A, don't forget now our support will now be at B, because you are lifting the object up now at A, the support will be at B now. So clockwise moment now will be the force that we assume that we apply at B, A, to lift the object upward. Let us find out that. So the moment or at this point will be 240 Newton, which is the force, times the distance from where that force is acting to the support B. And the distance there is 6 plus 4, which is 10. So 240 Newton times 10 will give us 2,400 Newton meter. That is the clockwise moment. Let's check the anti-clockwise moment. Anti-clockwise moment now is the 600 Newton times the distance of 600 Newton from support B. And the distance of 600 Newton from support B is 6 meters. If you look at it, the distance of 600 Newton force from support B is 6 meters. So therefore, the anti-clockwise moment will be 600 Newton, which is the force, times the 6, which is the distance. So our answer there is 3,600 Newton meter. Can you see now If you look at these two forces, compare these two forces, you notice that the force required to keep the object on the ground is 3,600 Newton. That is anti-clockwise. That is the force moving against your direction. And for you to lift the object up at point A, you need a force which is greater than 3,600 Newton or equal to 3,600 Newton. But what we got at that point A, our total force applied there is 2,400 Newton, as you can see. So therefore, this 240 Newton applied at point A is not sufficient enough to lift the end A. The 240 Newton force applied at A will not be sufficient to lift the end A because the turning effect due to the 600 Newton force is far greater than that of the 240 Newton. I think we've answered every question there. So let us proceed to the third question. A meter rule is found to balance horizontally at the 48 centimeter mark. When a body of mass 60 grams is suspended at the end at the 6 centimeter mark, the balance point is 30 centimeter mark. Calculate the mass of the meter rule, the distance of the balance point from the zero end if the body were moved to 13 centimeter mark. Now let's run through the question again before we start solving it. It says a meter rule is found to balance horizontally at the 40 centimeter mark. What does that mean? What does that really mean? That simply means that the center of gravity of this meter rule is found to be at 40 instead of 50. Already you know that a meter rule is 100 cm, and it's supposed to have its center of mass or center of gravity at 50 cm. But this particular meter rule is having its own center of mass at 48 centimeter mark, which means at 40 centimeter mark, that is where you have the maximum weight of that meter rule without supporting it with anything. So that particular point now, at that particular point, 48 centimeter mark, you have the weight of the object acting downward from there. The weight of the object to be acting downward from that particular point, which is 48 centimeter mark, because the 48 centimeter mark represents its center of mass. So therefore, the mass or the weight of the object will be totally acting downward at 48 centimeter mark. Now, without hanging any load on it, its mass is found to be at 48 centimeters. Now let us continue and suspend a 60 gram. So when a body of mass 60 gram is suspended at the 6 centimeter mark of the meter rule, so the one end of the meter rule now, from one end of the meter rule, 6 centimeter mark, I'm suspending a force of 60 grams, a force of 60 grams at 6 centimeter mark from point A. A force of 60 grams is suspended and is acting downward. Then if you look at the diagram now, you see that from the line I drew up at the upper part of the diagram, horizontal line, it's representing the 40 centimeter mark. It's representing 40 centimeter mark. And then the weight of the object is acting downward at that point. At that point, while the object is supported at 30 centimeter mark. So we have a pivot placed at 30 centimeter mark from the diagram. If you look at it, so the distance of the weight of the object now from 48 to where the pivot or the support is, how do you find it? You subtract 30 from 48, you are going to have 18. So therefore the distance between the support and the weight of the object is 18 centimeters. Now don't forget, we have already hung a load of 60 grams from end A at 6 centimeters. So now if you take away 6 from 30, 30 is the distance from point A to support is 30 cm. So for you to find the distance at which the 60-gram Newton, 60-gram weight is acting to the support. The distance between 60-gram weight and the support is 24 centimeter mark. How do we get that? Subtract 6 from 30, you're going to have 24. Now let us take moment. Let us take moment about the pivot or the support. If you take moment about the support, the object has two sides. The object can either move downward at the left side or can move downward at the right other side. So if the object is going down at the right side of the pivot, so the object is actually moving clockwise direction. But if the object is going down at the left side of the pivot, the object is moving anti-clockwise direction. So that is how to indicate clockwise and anti-clockwise direction. Now, taking moments about the pivot, the clockwise moment now must be equal to anti-clockwise moment. Now, the clockwise moment is the weight of the meter rule times the distance between the support and the weight. And the distance between the support and it is 48 minus 30, which is 18. So clockwise moment. So our anti-clockwise moment now will be 60-gram weight times the distance of that 60-gram weight to the support, which is 30 minus 6. That gives us 24. So our clockwise moment is 18 times weight of the object, while anti-clockwise moment is 60 times 24. Now if you divide both sides by 18, we are going to have 60 times 24 divided by 18. So the weight of this object, the weight of this meter rule is 80 grams. The weight of this meter rule is 80 grams. And we have answered the first question now. The mass of the meter rule. The mass of the meter rule is 80 grams. Sorry, not weight. Weight is in Newton. The mass of the meter rule is 80 grams. We are done with question A. Let's go to question B. Distance of the balance point from the zero end if the body were moved to the 13 centimeter mark. What the question is telling us that if from point A, that 60-gram weight with mass was suspended, if we move it down to 13 centimeter mark, you can see from the diagram now, if we move the 60-gram mass to a point 13 centimeter mark from the end A, now the support now will be shifted to in order for the object to be balanced. So if our support is shifted, what will be the new balance point? That's why I represent the new balance point as X, because it's not given to us. But don't forget, the weight of the object is still remain at the point where it's supposed to be its center of mass. So the center of mass of this object is still 48 centimeter mark. So now we found the weight, the mass of the meter rule to be 80 grams. So that center of mass, where center of gravity where the mass is acting downward, is now 80 grams. We replace that with 80 grams because we already have our mass. Now taking moment now, the distance of that weight W 80 grams to the support is now 48 minus X, because we don't know the new balance point. 48 minus X. Now the distance of 60-gram weight to support now is X minus 13. The reason we use X minus 13 is that the balance point must be greater than that 13. So that's why we do X minus 13. Now our clockwise moment now is anti-clockwise moment first. Our anti-clockwise moment will be 60 times distance of 60 grams to support to pivot, and the distance of that to support is X minus 13. That is anti-clockwise moment. Then our clockwise moment is the 80 grams times 48 minus X. So if you solve that, we divide both sides by 20, because 20 can go in 60 and at the same time can go in 80. So we divide both sides by 20. So our solution now becomes 3 into bracket X minus 13 is equal to 4 into bracket 48 minus X. So open the both brackets, evaluate for X. So at the end, our X is 33 centimeter mark. So the object will be balanced now. The new balance point will be 33 centimeter mark. So these are the solutions we solved before that some of you didn't understand it, so I've repeated it now. Please take note. Take your time to go through this, jot it down, and drop any question you have on it. Anywhere you are confused, you can still ask me questions. So we end the class now. So bye for now.